In this episode, we assemble our upgraded Allison transmission. Banks built, protected by AMSOIL, with support from Roadster Shop and Nitto.
Hey Clint, it's Gail.
Yo man, what's going on, brother?
What do you think of our little lockjaw project?
Oh yeah, man. I've seen some of the renderings of that truck. It is definitely sick. I'd love to be a part of that.
Well, we're gonna need one of your build Allisons. How do your units compare to stock? What's up with the internals?
You know, I mean, basically stock unit, we have obviously Allison, you know, full clutch packs and the co-pilot, all that kind of stuff. When we build it, I mean, for something like what that application is going to be, we're going to be shooting for more like the 1,000 horsepower build. So in that case, then we'll really go for billet shafts, billet input, billet intermediate, co-pilot. You know, in fact, instead of me talking you through it, why don't I just build you a unit?
Well, I'd love to see what goes into it. And if you don't mind, I'd like to keep it a little rat rod. So how about all black?
Yeah, I could totally do that. So give me like an hour, and I'll have the guys key up a case. Everything we have is purple. So we'll get a case that's painted black. By then I'll pull the shafts, get all the billet input, the intermediate, the planet, all this stuff put together, and I'll just build it right here if you want.
Clint, I'd love to see you build this bad boy. Let's get it on.
Right on, man, let's do it. I'm down for it. I can't wait to see this thing go.
It might get a little rowdy.
All right, let's get rolling. So we got a Allison 1000 here we're going to throw together. So I'm going to kind of show you the basics, you know, how they assemble. You know, the Allison is not a difficult transmission to assemble. There's a lot of little things that you do to an Allison to make it hold big power. If this is a stock application, the assembly would be exactly the same as what we're going to do here, but what we're doing here is all of the clutch packs we've upgraded, billet shafts, heavier duty components. As you know, the Allison is massive to start with. I mean, it's just big planets. You know, big shafts, about the biggest thing you're going to see in any light duty type of application. And of course, the clutch packs are pretty much mammoth, you know, again, because that's what an Allison does. They give us really big stuff to start with. What we're really going to change is like the clutch pack counts. So we've modified all the pistons. We increased the amount of clutches that go into it. So in essence, we basically maximize the amount of clutches that will go into the clutch pack. So you have the biggest clutches you can possibly put in there, the most amount of them, but also the steel to friction thickness compilation. When you modify, you know, if you sometimes adding more frictions will actually go backwards because the steels get thinner. So ideally, you know, what we've learned throughout the years is the perfect combination between how thick the steel is, what the steel is made out of, what the clutch composition is, what the material is, and that'll give us, depending on our static clutch or a dynamic clutch, dynamic clutches take a lot more abuse. So we're going to go with the friction material that has a little bit more ability to handle the heat versus a static clutch that basically clamps on and it doesn't have to do as much work. So a good example of that, of more of a static clutch, is your C1 clutches. Now you might say, wow, these are really small clutches. You see how big they are, how many there are. There's a lot of surface area. And there's also, they're single-sided, which means that, you know, you have frictions on every single one of them. And kind of what happens there is this clutch does actually have to release during the, you know, the 4-5 just for a moment. But what happens is it just releases and reapplies, so that clutch doesn't have to take much abuse. But this clutch is basically on in almost all forward ranges, especially the really abusive ones, which means when you put it in drive and you accelerate first gear, second gear, third gear, fourth gear, these clutches are engaged and they don't release and re-engage. So when you go with that type of a clutch, we'll maximize the mu value or the friction coefficient of this clutch to the steel. So it has the maximum amount of traction, but you actually compensate just a little bit on how much abuse this clutch will take. The reason we do that, because this clutch doesn't have to take much abuse, but we want it to be maximum holding power. So when this clutch is engaged and sits in the drum and is all squeezed together, every single one of these surfaces, you have an outer steel, you have an inner steel, you have an outer steel, and so on. That entire clutch pack, the way it is assembled in here, has to hold all of the torque of that motor. So you have your input shaft, which is hooked to the torque converter, and it's cranking on it. By the way, this input shaft is built, it's 300M. So it's much stronger than the factory shaft. And it's cranking on it. And then these stills, as I assemble it, you have your basically outer or your inner spline, right, that holds. Then you have an outer friction that has the outer spline, essentially assembles like so. And those grab this hub, right, and this hub is hooked to the intermediate shaft. So that's kind of how power transfer goes through the tranny. So I'm gonna stack this up real quick, throw it together on the money as far as clearance goes. Now the other thing, because this transmission is fully non-synchronous, which means that the computer is controlling the application rate when the clutch engages, when it disengages. A lot of little things in these trannies. I mean, snap rings, very small stuff. You know, snap rings are directional. You just got to be careful when you assemble it. You know, make sure it all goes together properly. You know, sometimes it's not much of a, it's not a huge deal as far as worrying about so much. In this case, how that snap ring goes in, but if you put it in backwards, you're going to play hell getting it out. So, you know, a lot of things are just basically kind of assembly aids. You know, how it fits together and that type of thing. So I always like to build a lot of specialty tools to check clearance. Certain clutch packs are easier than others to get to, right on the money. So, you know, we build all these parts, we modify, like say, the pressure plates, the reaction plate, everything. Then every steel, every clutch has a selectiveness to it, which means that we can kind of mix and match which steel, which friction. But ultimately, we want to get to the specific clearance, because the clearance on each one of these clutch packs as you're applying and releasing as you're going through the gears, that is what controls ultimately your shift quality. And you get really technical. The computer is controlling how quickly it brings that clutch is coming on based on the turbine pull down, and that's what affects the TCM programming. So kind of when you get everything dialed in right, the right friction component, the right clearance, the right hydraulic modifications, and then you add that with the TCM programming, then you get a transmission is going to shift flawlessly under lighter and higher power levels. Last thing you want to do is try to bring a clutch on that's too loose under really big power levels, then you basically get a flare. You put a lot of extra abuse in the clutch while it's trying to come on and overcome the torque of the engine, and that basically results in longevity issues. And we're going to go to our C2s. So we basically just put on our C1s. Going to drop our C2s in. You want to get everything lined up so it makes it easy to spline in a little bit. You know, splining in all these clutches sometimes when you have a big heavy drum. This is basically an example. This is your factory hub, this is a billet hub, so it's just a hardened steel versus the factory stuff. They just twist that at the planet. You know, again, when you start making that kind of power, it just breaks things. So you want to there we go. So now nice and solid, right where we want it. Got a Torrington bearing. Again, everything kind of runs on Torrington bearings. That means you can keep your end plates really tight. Torrington bearings versus thrust washers are kind of a huge thing, you know. And our input hub. It's the same type of deal with the C1s. Just kind of gently spline them in. Getting that last clutches. Okay. One of the little assembly tips sometimes when you're building these things is keeping everything kind of put together with some assembly lube. That just keeps things from floating around, and it just makes it easier to install the whole piece. And then of course, any clutch, when you get it down, you know, you have a nice solid. Now, if I was to float that clutch, you know, come up on it, for instance, I'm going to turn it. See how it's really not solid? That's kind of an indication. And a lot of these, I mean, when you start modifying the hubs and drums and clutch packs and that, you know, you only get so much room in the assembly. So You know, when you stack these things up, you know, if you have the clutch packs modified enough, you know, you'll fall off the hub one direction or the other, and then it all goes assembled in the tranny, and then you stack everything up. And if you stack everything up and you don't tighten up that end plate, then all of a sudden you have lateral load, right? So things start to move around. And once you get it together and don't set up the end plate, then things have a tendency of kind of flopping around there. So. All right, everything looks good. So that is basically our rotating clutch drum assembly, and you see it's hooked to the input shaft. So the rotating clutch drum assembly basically houses your C1s and TC2 clutches, which is generally first, second, third, fourth gear. Now remember, every clutch kind of comes on and releases, but this is a very important drum because it is hooked to the torque converter, which means that this guy is going to see all the torque of the engine plus the STR, the stall torque ratio, that's multiplied in the stator. So that stator is basically multiplying torque when fluid leaves the impeller and hits the turbine. Then once the turbine absorbs that energy and the oil exits the turbine, it's going backwards engine rotation, then it's redirected with that nice billet stator you saw, and that increases the torque. So you'll have as much as 2 times the torque hitting this input shaft that the engine's making. So that means if that engine is making 1,000 foot-pounds of torque, you can see up to 2,000 foot-pounds of torque on this input shaft. Hence is why the input shafts are one of the first to fail at big power levels, so we make it out of billet. And then that input shaft rotates the drum, and then the forward clutches, which I showed you earlier, are splined in, and then that's what rotates the gear set. So our rotating clutch drum is assembled, so we're going to set off to the side. So now we're going to roll over to the tranny. And you know, there's a few different ways to build. In Allison, you can kind of start from the front and go to the back. It just makes it a little cumbersome, or there's some little secrets. You can start at the back and assemble it, and then shim it up, and then flip everything over, and then stack it all up, and then you get a good way to basically build your end plate right out of the gate. So it's all preference. You know, little things. We got an air bleed here somewhere, if I can find it. It's a little air bleed in the top of the piston. So this is one of the hydraulic pistons that essentially goes in the case, and this is your hydraulic area. So your amount of square inches you have here basically times your PSI, your pressure, gives you how much lifting force you have on this clutch. And that lifting force essentially is what squeezes on these clutches. Kind of get an idea, and those clutches squeeze together, and that's what locks it to the case. So you know, one of these things you guys might be kind of wondering about, especially older clientele, you know, that has like say a 48 Dodge, for instance, or whatever. In those cases, you know, you're kind of thinking like, hey, where's the bands to this clutch? Well, you know, newer trannies don't have bands, but essentially anytime you brake something, when I say brake, these clutches are applied to the case, and that is essentially a brake clutch. The reason it's called a brake clutch or a brake band, because it actually ties it to the case, and that essentially is your brake that holds that part of the planetary to the case. So these clutches do exactly the same thing that your band would do. So put that piston in there, make sure it goes in nice and clean. Check your clearance. The best thing you do is a lot of lubrication on these guys, because you got rubber seals, you kind of push them together, and everything's pretty tight. So you want to make sure that everything stacks in there just right. Kind of the way an Allison works, we're going backwards, but the very back of it is our basically low clutches, or C5s, then you go your C4s and your C3s. So we're going to load in the C4s and C5s now. And little things going on here, you know, you need to make sure you you assemble the stills, right? Because all these lube slots, right? So there's kind of a dual function on these lube slots. They have two deals going on. One, lubrication, but the slots and the frictions actually are designed to create less friction coefficient when the clutch is disengaged. That means when it's disengaged and you're going down the road, that these clutches aren't dragging. So the last thing you want to do is have these clutches continuing to drag, and it basically eats up economy. It's basically an economy thing for the most part. You know, some of these, when we would build them in different applications, they would actually have, or we would build clutches that like have no lube slots or anything in them. It just creates a little bit more drag, and the way the clutches are designed today, you know, you can get a clutch that has a lot of durability and a tremendous amount of holding force, but it also, when it releases, it doesn't have a lot of drag. Sometimes you'll see scallops, just kind of, you know, different manufacturers do different things, but at the end of the day, you know, there's a lot of great designs that really work well. And again, I'm going to point out the size of these planets. Things are monstrous. And dropping our planets in. Good. Nice and solid. All right, now I got that all zipped down. Torque the bolts down, make sure they're good. You know, two-wheel drives in this part of the country are not the most common for us. All right, I think we're ready to roll. I'm gonna flip this bad boy over. Check everything's good. Everything's lining up nice. So the back part of the training's built. So basically what we did is we just put in the gear set, all the heavy duty stuff for the most part, billet output, billet intermediate, and C4 and C5 clutches. Now we're going to stack in the C3 clutches. Remember, we already built the drum, so C1 and C2, and then we'll finish it up with the pump. So I'm going to go ahead and stack in the C3 clutches. By the way, this clutch pack is what I consider the most important clutch pack. We take a lot of extra time to make sure we get as many clutches in here as we can. These are what you call your C3 clutches. These are always the most problematic. This is what has to come on in third gear and fifth gear. And they, have a tendency to take a lot of abuse. So, having our clutch clearance, the right stack up on this clutch pack is by far one of the most important. And then of course, as I mentioned earlier on the valve body, there's some pretty cool stuff we do in the valve body that allows these things to get full line pressure. One thing a lot of people just don't realize is the Allison doesn't get full line pressure to the clutch packs. You can put a gauge on it, but you don't know it actually gets the line pressure because there's no place to check actually clutch pressure. That is a pretty Haas snap ring. It's always nice to hear that. It's a nice thunk. All right, now we're going to build the pump. So I've got most of it put together. This is essentially the heart of the Allison. That's what your pump looks like, give you an idea. Another thing that the Allison comes with really nice to start with is a pump that's robust. Talking earlier about the overall in-play on it. Once we get everything together, our in-play means all of the clutch stack, the gear strain, everything. We want everything basically be down almost to zero, basically within about 10 to 12 thousandths, and that lets the things float. As it gets hot and the case expands, we have just enough in-play that everything is really happy. Now we're ready for the valve body. All right, we got everything pretty much put together, so the valve body's on. I'm gonna put the bolts in it. I gotta find my park neutral switch. I got it floating around here somewhere. But that basically has to fit in the case, and then the valve body is pretty much ready to roll, so I'm gonna torque the valve body. One thing that I've got to get for this one, because I understand the vehicle it's going in, I don't think it'd work very well if this guy was sitting on the ground, so we'll probably rip this off, and we're going to do one on our shallow pans. So that was an oversight because everything we build pretty much has a deep pan on it. So I'm going to find a shallow pan, get this valve body on and torque down, and then I think we'll cruise over the dyno and run this bad boy. Kind of what I'm doing here, I'm going to start with the valve body. Every valve body has a brain, and the brain is pretty important. What I mean about that is the hydraulics are half of the build. You can do everything great inside of a transmission. If you don't build the transmission brain right, which is the valve body, the hydraulics, then the tranny doesn't have a chance in living. So basically what I'm doing here is running through, this is the Allison valve body, Allison 6-speed, for the, basically the Banks Allison 1000 6-speed build we're doing. But what this machine does is this is basically simulates the vehicle, simulates the transmission, or each one of these gauges is the actual clutch pack. So what I'm doing is running this valve body through first, second, third, fourth, fifth gear, sixth, blah, 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 and seeing mainline pressure, make sure it matches our clutch pack. We have our C1 clutch, our C2 2 clutch, our C3 clutch, our C4 clutch, and our C5 clutch. So some of the modifications that we do here, and of course the Copilot is kind of one of those things which I'll talk about just a little bit, but what we're doing here is going through and making sure that every pressure in the clutch pack or the gauge is equivalent to line pressure. You know, this transmission makes about 275 to 280 pounds of line pressure. Once it's modified, it'll be just short of 300, the way I'll build the pump. The valve body, when we cycle through it, we want that clutch time to come on, ramp on to bring that clutch on so we don't get a too aggressive shift, and then depending on the engine torque, that's where the Copilot comes in, it will increase line pressure above, it will allow line pressure to go through the clutch pack. So the Allison, one thing many people don't realize, and if you don't have equipment like this, or if you haven't actually tapped into the transmission, you can put a gauge on the transmission, but you're not going to see clutch pack pressure. This actually tells us what clutch pack pressure is. And you'll see that we're low on line pressure, right? That's because the Copilot solenoid that we've installed in this isn't engaged. We're 280 PSI, we're only 165 in the clutch pack. That's typical of any Allison transmission, regardless of what hydraulics you do to it. You have to add the additional solenoid, then you have to modulate that solenoid at the end of the shift so it matches line pressure to clutch pack pressure. So what I'm doing through here is just running through the check to make sure that we're getting everything that we need. So in essence, what we're doing is the computer program modulates the solenoid, the solenoid runs low pressure to the spool valve cycles it in the valve body itself, the valve body spool valve takes line pressure, sends it to the trim valve. The trim valve then goes to the clutch pack, which is your transducer. So this transducer is emulating the clutch pack. So we're looking at what actual hydraulic flow through this valve body is. And once I'm done cycling through all this, then I will have a graph, a map that basically shows me everything that happened. First gear, second gear, third gear, fourth gear, fifth gear, sixth gear, fifth gear, fourth gear, locked up, fourth gear unlocked, third gear, second gear, first gear. And it'll graph all of this out. I mean, I've been doing this for so long, I kind of know exactly what I'm looking for. So I'm kind of cycling through it, but just looking for any anomalies. I will tell you, I'm excited about this build, man. It's gonna be really exciting. The way this valve body's come out, the way the transmission I'm sure is gonna come out. I can't wait to dyno this thing and get it to you guys. So I just want to thank you guys personally for allowing us to be part of this show and part of the build and working with you guys. We really appreciate you. And, you know, Banks, you know, you guys have done a lot for us. You know, the camaraderie, the working together, you know, something I've always wanted to do in the industry. I love this industry. I love the diesel industry. I love transmissions. I love hot rods. And more so, I love to see companies like ourselves working together to better the industry. So thumbs up to you guys. I'm gonna go back to work.
In the next episode, Gail lays the chassis on the ground and talks sheet metal.
Well, let's take a look at the renderings and see what we got to do.
All right, it's on.